Okay, can you guys see and hear me? Let me know. Want to make sure that everyone can see and hear me. So be sure to definitely all right, well, you can see and hear me. Okay, Alan, thank you very much for that. For some reason my public view is not showing up, so I just wanted to make sure you guys can see and hear me. All right, so tonight we're just going to do a very simple class that actually there's a lot involved with it. We're going to be talking about the profile toolpath. It's one of the most simplest toolpaths out there in the Vectric software, but there's a lot to it. There's a lot of options that you may not be aware of how to use, and things that you can implement into your profile cuts. Now, the profile toolpath is one of the only toolpaths, one of I think two toolpaths that can be used when cutting an open vector, a straight line, a curve, or something that's not closed. Most of the other toolpaths, such as your pockets, your drilling, your V-Carves, inlays, and things, they require a closed vector to work with. Well, the profile toolpath is one of our main toolpaths that we can use for a variety of reasons, and we can use them with open and closed vectors. Now, the reason why I want to explore the profile toolpath is because, we may be familiar with the basics of setting our start depth and cut depth and our bit, and whether we're cutting outside or inside the line or on. We may be, we're going to discuss some ramps and things, and then adding tabs. But under the advanced toolpath options, there are a lot of things that we may not be aware of how they affect our cuts and things, such as the separate last pass, or working with leads, our order, where we start, and corners, specifically corners. I want to really touch on that because that's something that is important. But so what I'd like to do is I would like to get into this and kind of get you even more familiar with this basic toolpath that we use pretty much very often in each of our projects and things. but give you some things to think about and some options that you can use for the future. So what I'm going to do is I'm going to come in and I'm going to create a variety of shapes. And let's see here, we'll do a line. And then last but not least, let's get some text in here. We'll go with let's see here, we'll go with a times New Roman, A, B, C, D, E, F, G. All right, so first off, let me welcome all of you and thank you for joining me. Sorry about the late, first of all, sorry about having to postpone Monday. We had a lot of customers that had to work with on Monday. We couldn't have class. And then, of course, the late start tonight. And the reason for the late start is that, I had a lot of customer calls to work through. But also, this topic isn't going to take a whole lot of time. We're probably going to be about an hour in to it, and to discuss these options and all. So on the screen, what you can see is I've got some basic shapes. I've got a rectangle, a circle, an arc, and a line, and then of course I have a letter. Now, the profile toolpath, when we're talking about the profile toolpath, it is again one of the only toolpaths that can work with a closed or an open vector, such as the arc or the line. But also it's one of the toolpaths that you can use any type of router bits, your end mills, ball noses, round over bits, V bits, decorative curved bits and things like that. So it's one of those toolpaths that use a variety of bits versus like if you were doing a V-Carve, which limits you to a V bit or like a ball nose type bit. It won't let you use an end mill and things like that. So the profile toolpath we can use any kind of router bit with. And so it is a, with the profile toolpath, we of course have to set a cut depth. How deep are we cutting and things? And the wonderful thing about it is a lot of times people associate the profile toolpath with cutting something out, if you're cutting out a shape or something, but it's also used when you're just following a single line. When I am cutting the profile of a shape or an object, I am following that single line, and that is my profile toolpath. And that cut could be, 1/16 of an inch deep. It could be 3/4 of an inch deep. It doesn't matter about the depth. We could either be cutting through the material or just doing a simple line outline cut with a particular bit. Now, when we generally create a toolpath, and in this case, I'm going to go with a end mill, 1/4 inch end mill. Seems good. Bear with me a second. I want to make sure that nobody's texting me to say that they can't hear me or anything, so please stand by 1 second. No, that was just a Facebook alert. Okay. So in this case, I'm going to talk about our rectangle first, and I'm going to go with a cut depth of 3/4 of an inch, cutting this part out. Now, a lot of times we simply just set our start depth, our cut depth, we choose our bit, and we decide if we're cutting on the outside of the line, the inside, or on. And I'm going to go on the outside of the line here. And then if we have to, we add tabs. If we're using double-side tape, we don't, kind of thing. And then we calculate. We never really get into the ramps, leads, orders, start at, or the corners and things. And so what we want to look at is what are these options, and how do they affect the way the cut is being made. Now, if I'm doing just a very simple profile cut, cutting through my material, It's going to, in this case, depending on the way my bit is set up to take an 1/8 of an inch pass. So it's going to do it in 6 passes. Now, I have control over the passes. I can edit those passes, and I can decide if I want to change that number of passes, increase it or decrease it, depending on how aggressive or non-aggressive I want to be. Now, I can sit there and say, okay, for the first pass depth, I may want the first pass to start out at a 1/16 of an inch, kind of break the surface type deal, and then to continue on from there. Or I could set the last pass thickness. If I wanted that last pass, maybe take some smaller bites or even bigger bites in the beginning, and on the last pass take a certain depth, I could set that as well. But I can also maintain an exact pass, tool pass depth. And so if I've set my depth up here and I maintain my pass depth and I set my passes, you see how it automatically brings me back to my 1/8 inch. It's keeping those passes even. If I change those passes to increase them, it's going to basically kind of break me up, and it's based on my tool pass depth. Okay, so if I use these set passes down here with the number of passes, it's going to break them up. And I could say, well, for the first pass, let's go ahead and set that to an 1/8 of an inch. Click apply, and then it's going to take that aggressive cut, and then it's going to take the smaller cuts the rest of the way through, depending on how many passes I want to do. And I could take less passes than the 6, and I could start out and say, okay, 3/16 might be a little bit aggressive, which is not really that bad, but I could say, okay, let's go, the first pass we'll just take an 1/8 of an inch, and then we'll go with the 3/16 each option after that. So we can change our passes by editing the passes directly, or we can come into our tool, and if we want to, we can change the pass depth here also, and that's going to affect the number of passes that we're working with. Now, the one thing is a lot of times, you may not be aware of this, but if we have our tool, if we come in here and make changes to the parameters in our tool database, then it's going to save those parameters. But if we click the edit button, then it's going to only change the parameters. I don't know why I'm running 3,300 inches a minute. Bear with me a second there. It's only going to change the parameters for that tool path. It will not change the default settings in your tool database. So if you do have to make a change on the pass depth, the step over, the feed rate, the plunge rate, if you have a spindle and you're changing the parameters on the spindle speed for that bit, anything like that, use the edit button versus the select. Use the select to select the tool, and then edit the tool to make the changes, and they're going to be temporary changes just for that tool path. So that's one thing that you want to kind of get used to doing. Now, when we are typically doing a profile cut, cutting out, generally we're cutting outside the line, meaning that it's going to cut with on the right side of the bit, and it's going to start and pass around in a clockwise position, clockwise motion, should I say, not position, a clockwise motion. And if we're cutting on the inside, then it's going to be making a count. It's going to be on the inside of the bit, and it's going to be making a counterclockwise motion. Counterclockwise motion. If we're on the line, then it splits the bit, and it is a clockwise motion, but it is cutting right on the line. We can climb conventionally, or in our direction. We can cut conventionally, or we can, or we can climb cut. Sorry, or we can conventionally cut. Now, when it comes to climb and conventional cutting, that is basically, are we going with the rotation of the router bit, or are we going against the rotation of the router bit? And that's going to ultimately affect chip load, and I've talked about chip load in the past and everything, but there's going to be times, depending on the grain of the material and things, there's going to be times, as a default, generally we're always climb cutting. But there's going to be times where we might be receiving a little bit too much chatter or cutting friction and things by climb cutting that particular cut, and we may want to conventionally cut. One of the things for this is, imagine if I was doing a series of lines surfacing a wasteboard, and I'm having where my cutter is coming across the grain, and then it raises up, comes back to the starting point, cuts again, instead of that back and forth motion. If I'm conventionally cutting, I am taking it's kind of going with the rotation of the router bit, and I'm going to end up on my wasteboards and all kind of receiving a little less tear out than I would if I was climb cutting, or the potential for tear out, should I say. And so if you haven't done so, or are unfamiliar with conventional and climb cutting, absolutely Google it and just kind of read the comparison. It's good information to know. Now, as a default, we're always climb cutting, but when is that occasion for conventional cutting come into play? That's what you want to know. When it may have something to do with grain direction. We're getting a little bit too much chatter in a climb cut, so we need to do a conventional cut for a cleaner looking cut or something. It could have to do with the prevention of tear out or chunking and things, but also our chip load, increasing or decreasing our chip load and things. Now, aside from that, we have, if I were cutting on the outside of the line here, when that toolpath starts, it's going to plunge down to the first pass depth, and it's going to go around the part, and then it's going to, where its starting point is, it's going to plunge down again, and it's going to continue plunging at that same spot, and that will end up leaving witness lines on our cut. So we have a couple of ways that we can prevent those witness lines that you see if you ever had to sand the edge of your board or the edge of your material, because you can kind of see actually each pass line, you can actually see that witness line going around the outer edge and stuff. Well, we have the option of doing what's called a separate last pass. And so what this separate last pass is let's see if I can draw my router bit. .25, and I'm going to take that router bit and I'm going to align it up against the outside edge. Alright, if I were to do what's called a separate last pass, I'm going to set the allowance for this, and let's say that I want to just do a 1/16 of an inch allowance. Then what that means is it's going to step the router bit away from the cut line, a 1/16 of an inch, and it's going to run that router bit along that profile toolpath at that 1/16 of an inch space on all of the passes all the way around until it gets to the very last pass. On that very last pass, it's going to step back over to the line and make a full plunge all the way down and do a single cut on the line all the way around, cutting our part out. And what that does is we have our full cutter taking that full last pass and everything, and instead of stepping down, so it removes or eliminates those witness lines that we would have. Provides us with a much cleaner edge that we can then very less sanding and things like that, that we don't have to deal with, especially if our router is just slightly out of trim. You know, it's a little unlevel. You can really kind of see those little stair steps, witness lines, you know, on the passes and things. If that router bit is not hitting, you know, perfectly 90 degrees to the edge and stuff. And so by doing that, we definitely want to have trim, because even doesn't matter if we're you know, doing the separate last pass, we don't want our profile cut cutting at an angle unless we were doing a chamfer. We want it straight 90 degrees. So you always want to make sure that your bit is running, you know, right angle or square to the material. But those witness lines will be eliminated because it's going to cut at a distance away from the material all the way around for however many passes. In my case, 6 passes, so it's going to do 5 passes at that 1/16 of an inch away from the border. And then on that last 6th pass, it's going to step over to the line, plunge straight down, and it's going to cut all the way around. And what that, again, what that will do for me is that will relieve all those witness lines. Now we can actually reverse the direction on that last pass to where actually instead of if we're doing climb cutting, you know, our typical climb cutting and everything, we can come on that last pass where it will reverse the direction and do a conventional cut. A lot of times that will give us a very clean, nice mirrored edge in a sense. If we reverse the direction on that cut, it's not always necessary. It's not required or anything. But next time, if you ever end up using this do separate last pass option and all, try it. Do a sample cut with the reverse direction unchecked, and then do one with it checked, and just look at the difference and everything between the two. You'll be surprised at the slight little difference and all. But in this case, I'm going to take my rectangle here. We're going to do a 1/16 of an inch last pass, separate last pass, and I'm not going to reverse the direction on this. I'm going to be on the outside of the line, cutting 3/4 of an inch my material, and I'm going to calculate this tool path. I'm going to cut through. Oops. Bear with me, my material thickness is 0.39 inches for some reason. Stand by here. Don't know where that come about. Let's try that one more time. Outside of the line, 1/4 inch end mill. Got a little gremlin in my software. Alright, so a 1/16 of an inch separate last pass. I'm not going to add any tabs. I'm not going to add any ramps, leads, orders, start outs, or corners. Just a very simple profile cut with the added function of doing a separate last pass. And so I'm going to go ahead and calculate that tool path. Now, on that cut, let's see if I can get this to slow down a bit. Oh, not that slow. How deep am I cutting here? Let's try that one more time. Come on there, Laney, you can do it. It's 0.75. There we go. Alright. The first thing you'll notice is if we look here on our G code, we've got our top 5 tool paths that are 1/16 of an inch away, and then our 6th one here is in on the line and everything. And so let's go ahead and one more time, let's turn off that color and let's preview this tool path. Let's actually reset and preview that tool path. Alright, so that's pass 1, 2, 3, 4, 5, and then it steps over, and you can see that here. I wanted to stop it. Let's kind of get this straight up on. So for those first 5 passes, it was cutting out away from the material, that 1/16 of an inch, and then on the last pass it's going to take the full plunge of the cut, the full 3/4 inch cut, and now it's going to come through and cut that part out. And what that does for us is it really keeps us with a nice clean edge that we have to do less sanding. Well, let's take this a little bit further, and let's actually talk about our witness lines. So doing our separate last pass is great and all, but where's our bit actually cutting? Where is it doing that plunge? A lot of times it will just pick a spot, and it will come in and it will start plunging, at a certain area, a certain depth. And in this case, if we noticed the toolpath, and let's see if I can get the toolpath to light up on here. It's right here on these start points, and depending on my vector, and in this case we have nodes, 4 nodes on this corner of this rectangle, the 4 corners. It's starting right here on this bottom corner node, meaning that my bottom corner, if I would not have done a separate last pass or anything, my bottom corner, you would see that you would not only see the witness lines on the material, but also right here you would actually see kind of like a little cut where that bit is sitting idle, but it's just plunging down to the next step, the next step, the next step. And you actually see those steps, very visible in that corner and things. And so in this case, it's not too bad, being right there on the corner and all, but it could, depending on what the design is, this is just a basic rectangle, but those start points could be, starting in the middle of the job and things like that, where it's really noticeable right on the edge of the board. And if we ever have the opportunity, we want to, try to start in a corner. And how we do that is we make sure on our vector, if I go into node edit mode, you can see where my start point was. But what if my start point was here? Then my bit's going to be plunging in the middle of this cut all the way around. It's going to stop and plunge, stop and plunge, stop and plunge. And so not only am I going to get witness lines all the way around, but I'm going to get this nice little half router bit, or a small little curve cut in my board and things. And I don't want that right in the middle, or right on the side where it's visible. I want to kind of, if I have the opportunity on any project, somewhere that is out of way. So I definitely want a corner to be a start point versus the middle of the field, if I have one. And how do I get it to guarantee that the project will start at the start point? Well, that is in our our advanced options here. And in our advanced options, and it doesn't matter, even if we're doing pocket cuts and things like that, we always have the option, but we have our Start At tab. So we could keep the current start points. We could optimize the start points, and what that does is that means it's going to optimize if I have more than one object being cut out. It's going to optimize and make the start points the closest points to one another between the objects. And I want to, if I optimize, then it's not necessarily always going to start on my vector's starting point. It's going to actually choose its own starting position, and it's going to optimize those positions that are going to make the toolpath closer, so there's less rapid movement from one object to the other. If I don't want it to do that, if I don't want it to kind of pick and choose, then I'm going to maintain my start point. And you see that start point light up there. I want to keep that current start point, and it's going to always start in that corner. Or, if here my start point is there, I could actually, on my node editing, I could right click and say make this the start point, depending on which way I want to start it from the line. and I can keep those start points, so that's where my bit is always going to plunge and cut. Now I can actually move the start points to be the closest to the selected point on the vector bounding box, and so meaning that if I have a what am I trying to say? The vector bounding box is, our nodes here, and if I have a vector selected, I can keep it to where it's going to start as close as possible to that starting point. So it's going to actually move the starting points to be the closest to the selected point on the vector bounding box that I have selected, on that vector that I have selected. And so we can tell it, do I want to start in the middle? Do I want it to start as close as possible to the corner? Things like that, and which corner do I want to work with? So we have 3 options of where we can start. Me personally, I like to start at my starting points, and then from time to time, I know that a rectangle is going to be one of the corners, but on a certain shape and everything, the starting point is up here at the top of the circle. Well, I may want to, change that starting point. I don't know, insert a point here and make it a starting point there, so it kind of starts from this area here. And it might be due to the fact, and this is a circle, I'm cutting out a circle here, but this could be due to the fact that it is in an inconspicuous area. If I'm not using like the last pass option or things like that, if there were going to be tool marks or anything like that, then I'm going to put it in to where it starts in a kind of an inconspicuous, let me learn how to say that, area that that's not going to be visible, like in this project, hanging on the wall or something like that, and I'm too lazy to sand it out, or I don't want to have to sand a big old divot out or anything like that. It's just something that we're out of sight, out of mind kind of thing. So I'm going to choose that point, that inconspicuous point, and I'm going to make that my start point, and then I'm going to make sure that my profile cut, my pocket cut, whatever cut I'm doing, uses the start points. Now in the 2D profile toolpath, that is under the start at options. In a pocket toolpath or anything like that, these options, where are the options? Bear with me. Show advanced toolpath option. Clear bucket line. Oh, the pocket toolpath doesn't have that. Wow, I know the V-Carve does. Yeah, V-Carve has the option to use start points. That's crazy that the pocket toolpath doesn't. Fluting doesn't. Oh, see, we're gonna have to get into all these tools one day. We're talking about the profile toolpath today, Bo. But so where's your vector going to start? Where's your cut going to start on your vector or on your object or on your shape or design and things like that? Do you want to do a separate last pass if you're cutting that part out? Now, of course, if you're doing just a shallow engrave type thing and you're cutting out, doing a separate last pass is irrelevant. It's only really for when you're cutting through the material. Now, let's talk about a combination of a couple of things. So let's go back to our rectangle here, and I've got my starting point in the corner. And not only am I going to have my starting point, but I'm going to also look at things like the order of the cut, but also leads and ramps. I'm going to talk about those. Now, it's always a good idea to ramp into a cut whenever possible, because that prevents less wear and tear on the router bit. It helps extend the bit life and everything. But also, it's less aggressive on that cut when it's coming down and making that plunge instead of a straight plunge down into the wood and cut. It's going to ramp in some way. It's going to either zigzag into the cut, making a nice shallow cut and slowly cutting down to the depth that it needs to be. it's going to, it could be a spiral plunge where it kind of creates a circular motion and then start dropping down slowly until it gets to its cut depth. It could be a smooth motion, depending on what you're doing, where it's kind of like a half, it just as it smoothly comes in to that cut. And I've always, you might have heard me in other classes, past classes, talked about when you're doing a profile cut using the spiral toolpath. The spiral toolpath is a wonderful toolpath that you don't necessarily have to do the separate last pass if you're using a spiral cut, because the spiral ramp, not only does it extend help extend the life of the bit by less wear and tear on it, but also it helps eliminate those witness marks as well. But let's before we get into ramps and all, because ramps kind of ties in with leads. Let's talk about leads for a minute. Now, a lead on a cut, and let's look at our 3D profile toolpath. Let's kind of get back in here and reset this, and let's make our toolpath visible. Okay, let's get this where you can see. All right, so the red line is my router bit traveling over to the object, above the wood and all, and my green lines are where it's making that plunge. So it's right now there's no ramps, there's no leads, there's no anything. It's making a straight plunge. It's coming around and cutting, making the second depth plunge, coming around and cutting the third depth plunge, so on and so forth. Well, remember me talking to you about that, as that bit is plunging down more and more, it kind of creates that little divot in the edge. Well, we can avoid that by adding leads to the toolpath. A lead is you can use a straight line lead, a circular lead. Circular leads are always good, a nice swooping lead and everything, they're always good, but you can use straight line as well. You can set an angle of the degree, and what that does is, and I'll go ahead and I'll do a straight line lead at 30 degrees, and I will calculate that. And what you will see is, if I can move this over, you will now see these extra vectors in here. And what the software is doing, or what the toolpath is doing, it's taking advantage of the waist area of the cut, and it's considering anything outside of this vector waist area, but it's going to ramp, it's going to come down here, instead of way up here, it's going to come down here, and it's going to lead into that cut and just make a nice motion all the way around. No pausing, stopping, no pass and go, collecting $2,000, whatever. It's going to come in, it's going to lead into the cut. And that, as it steps down, it's going to lead into the cut. And that will, all of our tool marks or anything like that, any kind of, issues we would have would be out here in the waist area and not on our toolpath. And so if I were to preview this cut, you will see that as it plunges down, it will lead into that cut all the way around, and it leads in and does a nice little 30-degree turn and just a nice smooth motion and kind of comes around. It's leading into it, and that's going to eliminate that divot mark if you were just plunging right straight down on the edge of your board. Now let's look at, if we come in here and let's look at our leads, and let's look at our circular leads. So we can either set a radius or a lead distance, a lead length, and in this case I would generally probably, let's say, quarter or a half inch, probably a half inch, twice the diameter of my bit. I would set that. Now you can reduce the radius of that circular lead, you can increase it and everything, however you want to do. you can have it do a lead out, meaning not only, when it comes in and, leads into the cut, when it gets around to that final cut, it will lead out away from it. It'll just do that nice smooth finish and then lead out. That'll keep that bit away from, just kind of stopping and then raising up on its final, on its final pass, raising up and then possibly grazing a nice little cut line, in the edge of our board that we just, work so hard to keep in our, our edge clean. We can actually just have it as it finishes it up, it leads out of the cut, on its final pass. And so if I came in with a circular lead in, lead out, let's reset our preview so we can see our lines here. You can see that it will come in, it will lead in to the cut, come around, and then it will lead out, raise up, come into the cut, lead in, come around, lead out, raise up, and it creates that kind of lead out motion away from, again, so it's not raising up. Leading in is supposing, we're helping it kind of eliminate the tool mark and all, but if we have it just raising up, to move to the next lead in, well, that's kind of a little bit defeating the purpose. So, we want it to lead out after that pass and then raise up and come over, lead in and lead out type of thing. So if we were to preview this, and let me slow it down a little bit, it's going to lead into the cut, lead out, lead in, lead out, raise up, lead in. Let me see if I can slow that motion down a little bit more. So as it comes around after that nice lead in, let me know if you're getting any buffering. I can't tell today, guys, so let me know if you're getting any of that. And then it's going to lead out away from the cut. It's going to raise up and move to the next lead in. And, again, all of these things, to optimize our workpiece, the result of the end cut and things like that. And also, help with our, extending the life of our bit. Now, the lead in and lead out and all the leads aren't helping with extending the life of the bit. It's our ramping that does that. So we'll go ahead and stop this. We don't need to see any more of it. All right. So if we come back in here, now that we have our leads and everything, we can now come in to our ramps. Now, one of the things that you'll notice right off the bat, okay, good, thank you, Chuck. One of the things you'll notice right off the bat is when you have leads, when you're using leads, whether straight or circular, when it comes to ramping, the spiral ramp is no longer an option. Because essentially, the spiral ramp is a lead in itself. It's kind of leading in, and everything to that cut. And so when we have leads selected, we have only two options for how we ramp to those leads. Do we zigzag in, meaning the bit's going to kind of zig into a, from a shallow depth down and then to another depth to our final cut and then lead in? Are we going to do a smooth lead where it's just kind of a little additional circular lead, to our ramp? Keep saying lead. To a little circular ramp to our lead in. Again, so it's not just plunging straight down in the lead into that 1/8 of an inch or whatever my pass depth is. It's kind of gradually cutting down to that depth, slowly starting from 0 down into the cut till it gets to the depth and then around and all. And so if I were to, use a smooth lead, I could also, from, the zigzag or the smooth and things, I could also, just ramp on the lead in. You know, since I do have leads, I can just ramp on the lead in, and that will eliminate any options. You know, when I have this here, when I'm choosing a smooth or a zigzag type ramp, I can choose the distance, how far it ramps away. I can choose the angle and things like that on the ramp and stuff. Well, if I just check off ramp on lead in, well, now it's going to take the information from my lead, and it's just going to do a ramp cut. It's going to add a ramp cut to the lead cut here on the ramp on lead in. Now, it's not going to ramp on the lead out, just the lead in, you know. So if I were to go ahead and do a smooth ramp on my lead in, and I've got my leads selected and everything, if I calculate this toolpath, we can see a little bit of a change. So instead of our blue lines like our lead out, we've got this kind of green line, and a green line kind of indicates a ramping motion and stuff. And let's see if I can get this turned in a way that, bear with me a second, it shows in, it shows the cut. So it's going to ramp, do a ramp motion and everything into the cut. And if I, let's see if I zoom in. Kind of a, let's see here, where's my, right here is my normal start. Oh, I'm sorry, right here, this green line here is my normal start point. The green line here is kind of the start point of my where my lead in is starting to make its turn to make contact, and then these are going to be my ramps as they lead in. So let's preview and just kind of see what this cut's going to look like, and let's see if I can slow this down and let's preview this. Now what is happening, let's stop right there. Let's stop. Is if you look, oh, let's turn the color off. So if you notice here, instead of plunging straight down on the lead in to the 1/8 inch depth and then just kind of leading in, what it's doing is it's starting from the end of the lead and it's slowly ramping down to that 1/8 inch depth. Again, helping extend the life of our bits by less wear and tear, taking less of a cut, you know, a little bit more, a little bit more, a little bit more till it gets to that end. And it's doing it on that lead, that circular lead into the cut. So we're not taking an aggressive. If we turned off the ramps and we preview the toolpath, it's coming on that ramp, it's coming down, straight down to that 1/8 of an inch and then sweeping in on that ramp in cut. It's not, or ramp, on that lead in cut, sorry, I'm getting my tongue twisted and all. And it's just taking that full 1/8 of an inch depth of cut from the beginning of the lead in till where, you know, starts cutting the profile of the toolpath. Well, if we ramp, it's going to just do that nice subtle cut until it gets to its point where it starts making the shift into the profile toolpath and all. So again, we are leading into the cut to help eliminate tool marks and things like that on our material, and then we're adding ramps to our leads on that lead in to help with the keep, you know, our bits nice and, you know, long lasting and things. And you have so that's a smooth lead, just a very smooth ramp, you know, type of effect and all. On the zigzag, if I were to calculate that, you can see this, you can see my lines here, kind of this zigzag motion here in the toolpath lines. If we reset this and we come in to a, it's going to start at a particular depth and it's going to come down and it's going to come back to, you know, another depth, and then it's going to come down to the final 1/8 depth. It's zigzagging down to that 1/8 of an inch cut and then it's taking its lead in. So it's kind of zigzagging back and forth, taking a little bit more material off here and there and things. And so you are zigzagging into it versus just doing a smooth ramp. You're kind of zigzagging, take a little bit more material, come back, take the rest of the material, and then come back and do the cut. Leading in. Those are the two options between zigzag and smooth. Now, let's take a look at, optimizing this. So we're going to do a 1-inch lead in, a radius with a 1/2-inch lead in. That's good. I'm going to do a lead out and overcut distance. None. I don't want an overcut distance. Overcut distance is where it overcuts past the starting point of the actual profile cut. It overcuts past that before it leads out. If I set, and let's take a look at that. If I set this to say, I don't know, let's do an 1/8 of an inch, or 1/8 of an inch. You can see now that my lead in and lead out are separated, so it kind of overcuts past that first pass before it leads out. And so it leads in into one area, comes around and does the profile cut, and then comes past that beginning point and then leads out away from it. So you can set that. You don't necessarily have to, but hey, it's another it's another added option. Now you're not coming in and out on the same point as well. And some of these things you should really do some kind of test cuts just to see the differences between them and how everything reacts and all. Now, jumping back over to ramps without leads, the spiral ramp, which leads has no roll with it, it's kind of by itself. The spiral ramp, what that does is, if we zoom into our Toolpath preview, this is going to take a barely kiss the top of the board, and as it comes around, it's going to just take a smaller and smaller depth. I watched Toolpath in the TNG software, and it was taking about a slow ramp of about 20 thousandths of an inch, 0.02 thousandths of an inch, as it was going down, and it was taking more and more. And all it's doing is it's getting lower and lower and lower and lower and lower and lower and lower as it comes around, taking that 20 thousandths of an inch until it gets to that final pass, taking that cut. So if we were to preview this, it's barely kissing the wood, and you can see it's only taking a few thousandths of an inch, and it's going to continue that way, but it's going to start getting deeper and deeper and deeper and deeper into the cut. As it goes around, it's going to start getting deeper and deeper and deeper. It's making a very, very small ramp right now, getting ever subtly so deeper and deeper and deeper. And if I speed it up just a little bit, as it makes the turn, it's going to get deeper, 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 and it's going to continue taking that little depth, that little ramp, all the way around until it gets down to its final pass. And you'll watch as you're doing a spiral toolpath. If you ever watch your Z box and your absolute measurements and everything, you'll see that Z just continuously dropping and everything. So a spiral toolpath, it basically is not essentially necessarily a lead in any way, because we're not actually cutting away from the wood into it. It's actually coming down and cutting, but because it's taking such a subtle cut all the way around and things, those witness marks are virtually eliminated on those edge cuts and everything. So definitely, hey Baron, how are you doing, buddy? Definitely something that you want to check out. And let's go ahead and stop this. Let's stop this cut. So we can go back into here. And ramping is there's nothing absolutely wrong with ramping at all. It's always a good idea to add ramping of some sort to your profile cuts or your cuts and all to help extend the life of the bits. And again, not necessarily just your profile cuts, and things. I think most all, and let me verify before I start speaking out of turn, most all toolpaths, the pocket cut has the option to add ramps. Now it doesn't give you options of spirals and things like that. It's just a simple zigzag ramp. Okay. The ramp distance, usually I go twice the diameter of the bit, but you can go more. So our pocket cut has the ramping option. Let's see here. The V-Carve has the ramp option. I think most all of them are going to have the ramp option, except for this, because it's kind of fluting is kind of ramping in a way. Let's see here. Texturing doesn't have it. Prism carving doesn't have it. Molding toolpath has it. Yep. So, whenever possible, it's a good idea. Now, adding ramps to a toolpath extends the length of time, the run time. Keep that in mind. But I don't mind running a little bit longer time, if it saves me money on replacing router bits very often, type of thing. You know what I mean? It's a decent trade-off for me. I don't mind the little extra time for those ramps and those motions and things like that if it's going to help extend the life of my bits, meaning that I'm replacing bits, not as frequently as, I would if I wasn't ramping, Yep, Bob is correct. The one thing... I hadn't gotten there, Bob, but that's awesome that you remember that. Bob says, hey, isn't this feed rate and the plunge rate supposed to be the same when you're doing a spiral toolpath? And yes, it's not 100% necessary, but it's absolutely so much better that if you are going to do a spiral ramp, that you edit your tool and you make your plunge rate match your feed rate. Because, and this is a terrible analogy, but think of a toilet flushing. As it's going around, it's going down, that nice, smooth flow, all at the same pace and everything. We want our bit to be dropping at the same pace that it's feeding, as it's making its cut and all. We don't want it to have to pause, and it becomes jerky. It becomes kind of jerky if it has to slow down for that plunge, that dropping kind of motion, because it's dropping as it's making its cut, it's constantly dropping in depth. And we don't want that jerking back and forth, of between 20 and 50, 20 and 50, 20 and 50. We want that, that 55 and that 55. We want that plunge and that feed rate to be the same, whatever your speeds are. I'm not saying it has to be 55. Whatever your feed rate is, you want the plunge rate to match. And that would be the only time that you're going to have your plunge rate match your feed rate is when you're doing a spiral ramp on a profile cut. All right, you want it just like a toilet flush, and you want that water going down and around at the same time. So, thank you, Bob, for pointing that out and everything. So, with spiral ramps, you want to make your feed rate match your plunge rate, or your plunge rate match your feed rate. Sorry, your plunge rate match your feed rate. All other ramps and zigzags and things like that, you don't. You just as is. Okay. But get to looking at the the leads and everything. Now, again, like I said, leads take advantage of the waist area, and also let's look at our circle. Let's look at our circle toolpath here, or our circle vector, and let's add a lead. We'll do a lead out with no distance. And we're going to be on the outside of the cut. Let's go with a 1-inch lead. Now, where that lead in and lead out is, okay, is going to be very close or next to my start point. So if we look at my vector, my lead in and lead out, okay, if I actually looked at the vector and went into node editing mode, it's going to be leading into where the start point is on my vector and leading out from that if I don't have any separation. In this case I don't. My lead in and lead out areas are the same. And so it's kind of basing on that start point. So if by chance this area to the lower right of the circle was not waste area, maybe there's something else being cut out of here, then I would not want my lead in and lead out to be in this area. And I'll give you an example. Let's make this a start point, and let's recalculate this toolpath. Okay. All right. Now, granted that my rectangle and my circle are far enough apart that when my bit plunges in here and comes and leads in and leads out, it's not going to affect my rectangle cut, right? My profile rectangle cut. But what if our spacing was, you know, closer together because this, you know, it was, you know, text or something or whatever the case may be, you know, like 2 letters and 2 words and things. We don't want our lead in and lead out to be in a main area. We want it to take advantage of waste area. So if I have to come into node editing mode, and if I have to, you know, make, you know, a different start point and then recalculate that toolpath to take advantage of that waste area, then I'm going to do so. Absolutely. You know, you don't want it cutting into the area of another vector, especially if they're close and all, because you don't want it damaging that vector. Now in this case, like I said, if I were to, you know, because of the spacing between my rectangle and my circle was wide enough that the lead in and lead out would have no effect on my actual profile cut, 2 separate areas and all, then it's not a problem. But, you know, it's something you got to be mentally aware of, because it would suck to be going like, oh, why is that cutting? Oh, why is that cutting over there? I don't want it to cut there. After you're like 2 hours into a project type of thing. It's yeah. Bob asked a great question. Does it help on plywood cuts? Yeah, I think it does, because it's, well, now, all right, I'll say yes and no. And here's the yes and the no part to that. Yes, because a spiral ramp or a lead in and things like that, we are kind of breaking that surface of that veneer, and we're not just plunging in and taking a full plunge all the way around, which causes that chipping and fraying and stuff, especially if we're using an upcut bit. By the way, if we're cutting in plywood, we should be using a downcut spiral or a compression end mill, but a downcut spiral is fine enough, because you don't want any of that chipping and all. An upcut, now even a straight 2-flute spiral or 3-flute, you know, straight bit, those are great for plywood as well too. But an upcut spiral, definitely not. You don't want an upcut bit, because that's going to definitely cause chipping. But the ramping and everything, you know, the spiral ramp, in my opinion, yeah, it does help with, you know, keep the cut clean, because it's kind of breaking that front surface up. But now, and that, you know, that's kind of my thinking and my opinion that it does. But here's the no side to that. What if I'm using a, you know, a very, you know, cheap plywood, purchased at Lowe's or Home Depot and things, and my bit is just grazing the top of that veneer, getting oh so deeper and deeper and everything, and my bit or my plywood's not the greatest and everything, aren't I just actually just kind of just asking for it to just kind of just start chipping up all the way around that circle, you know, just start tearing out and everything, because my bit's barely just kind of cutting into it and all, and everything. In plywood, a lot of times when we do joints and things, dado joints with our router and stuff, sometimes we'll actually score the lines, the outlines of that dado to break that surface, so when we do cut out that dado, when we're handheld routing and things, we're not, it's going to reduce the chip out. We take a box knife or a blade and we score a scoring knife or something, and that helps reduce the chip out when we're running our router back and forth and all. Well, if my bit is grazing the top of this surface, is it getting to that particular depth where it just starts fraying it, fraying it to hell? Or is the fact that it's taking a smaller cut and everything, meaning that it's going to provide a cleaner cut on the plywood? I think that answer is kind of, in a sense, based on the plywood itself. I think a furniture grade Baltic birch or something, or furniture grade plywood in general that uses more veneers, better glues and things like that, are going to perform much better than a 4 or 5 ply plywood or something that I'm buying from Lowe's or Home Depot. I just think I'm going to get a better quality with a furniture, with a higher grade quality plywood. So, yes and no, Bob. As far as helping on plywood, I think yes, mostly it is, but it really depends on the plywood. That's the only answer I could get. That's the only answer I could really give on that one. All right, so let's dig back into our profile toolpath, and let's talk about our arcs and lines and things. Well, imagine, and let me hold down my control key and let me drag, a couple points and all. Let's imagine that I'm doing, I'm cutting a particular type of wood, and or MDF or something and all, and I want to make sure that all my cuts are running in the same direction. Now, that is mostly going to be dependent upon my start points. So if I go into my nodes, I can see my start points are here and things. Now, do I want to optimize this toolpath, meaning that when this router comes and this bit comes and cuts this line, it's going to raise up and it's going to come back and start cutting this line. Raise up, come back and start cutting this line. Raise up and come back and start cutting this line. Well, do I want to alternate that? Do I want every other, line start point to, to start there? So that way when my router is cutting, along here, it's coming back now and it's starting on this start point, cutting this direction. When it finishes this cut, it moves over to this start point, cuts and everything. And now that optimizes my toolpath, makes it a lot smoother. I'm reducing all the time of it raising up, coming back to the start point, and starting from that line again. Now, on that note, I definitely want my start at to keep current start points. I definitely want that selected so it does do that motion, that cut, move over, cut, move over, cut, move over, cut. If I'm in just kind of the default optimized start points and things, it may do that for me, right? It may alternate for me. Sometimes, depending on what it is, sometimes it's got a mind of its own. It just wants to raise and come back. But if I intentionally want, when it cuts this line, to raise up, come back, and start and cut this line again, because I want to cut in a certain direction across that grain, with the grain type thing, or what have you, whatever the case may be, or I want to reduce tear out, and an MDF or something, if I'm kind of back and forth, I could be, getting tear out where I don't want it. So I'm going to make the bit cut in the same direction for each and every pass. And that method I would come into my and make my start points all on the same end. And for that, that's when I'm doing a spoil board cut. Oops, I don't know why I want to node editing, you sucker. Node editing. There we go. When I'm doing a spoil board cut, the first thing is when I'm cutting and everything with my spoil board, it's a pocket toolpath and stuff, and we're talking about a profile and all. I usually have kind of a rectangle drawing, but a lot of times I will draw a series of lines depending on how I want them to cut and things in the area. And every single one of those lines, the start points are in the same direction. Okay? And I'm going to, first off, I'll end up having a rectangle around. Imagine this is my spoil board. And I will end up having it do a profile pass on the inside first, or I could have it doing last. But then on these individual cuts here, I'm going to have it start at the start point. So I'm going to have it start in a corner. So let me go into node editing here, make that corner start point. That's fine. And I'm going to calculate this toolpath, taking, we'll just take 1/8 of an inch off. I want to be on the line, and I want to ramp in. A smooth ramp is fine. The zigzag, whatever. I'm going to have it ramp in to that cut, but no leads, not on this. But the start, I want to keep my start points. So it's gonna come around. It's gonna do my profile toolpath. And the reason why it's going to do my profile toolpath first is because on my order, we haven't talked about order yet, but on my order, I'm going to use the vector selection order. And what order did I select it? I selected the boundary first and then my 3 lines. So it's going to cut the border first, then my lines in order. I'm going to use that vector selection order. That's the order. We haven't talked about order yet. I haven't gotten there yet. But now my router is going to come and it's going to do that profile pass, taking that, 1/8 of an inch cut, and then it's going to raise up. It's going to make that pass. It's going to raise up, come back to the beginning and make that pass. Raise up, come back to the beginning, make that pass, raise up, come back and make that pass. And so now all of my cuts are in the same direction, and I have less chance, especially if I have it set to a conventional or a climb. I maybe want to climb cut this for a nice smooth cut, or conventional. I keep saying climb. I do want to climb it, but I may want to conventional it for something, but you typically want to climb. I don't know. I don't want to confuse you with climb and conventional, but and I want to optimize. I want to stay in that, because if I was not, then I would be climb cutting, conventionally cutting, climb cutting, conventionally cutting. I want to climb cut all the way across type of deal. I don't want to climb conventional, going with the grain against the grain, or with the rotation. I keep saying grain, with the rotation of the bit against the rotation with the rotation. So it all depends. But so vector starting points we talked about earlier, or start points. We can, when you are using it for a specific reason, by actually selecting your order, or you want it to only work with a particular start point, then you want to keep your current start points. If you have optimized start points, then it's just going to optimize. It's going to just, not necessarily on the corner, it's just going to drop somewhere that's close. It's going to cut and things, and then it's going to move over to the nearest point of the next vector, and it's going to cut and it's going to optimize that toolpath to make it faster and things. You don't always want that. You want to specifically start on a start point, and so you make sure you use your start at selection. Okay. Now order as a default, left to right, bottom to top, and in a grid pattern. Okay. It's going to look at our toolpaths and everything, and it's going to select the furthest most left part of the job, and it's going to cut from left to right. It's going to work from the bottom of our board, not the depth of cut, but the bottom of the board versus the top. Your one edge versus the other. It's going to start at the bottom, closest vector from the left side, and it's going to work its way towards the top vector, heading to the right, of the board and everything. Other than that default option, we could say use the shortest path, right? So it's going to pick the shortest path from point A to B. Where am I going to go to get me to the shortest path? Or we can use our vector selection order, and what I would normally do is, if I am starting at and keeping my start points, then I'm probably going to say something like, keep the start points, but work in the shortest path. So keep the start points, but move in the shortest direction from those start points to save on time. Or I could decide to just, let the default go, work in that grid pattern from left to right, from the bottom to the top type of thing. That is our default. Or I could say I want to use my vector selection order, meaning that I have specifically selected my vectors in an order and I want them to run in that order. I could say I want this one to run first, this one to run second, this one to run third, and then I want it to cut my profile, this line, this line, this line, and this line. That vector selection order. If I calculate that toolpath, it's going to cut my rectangle first, my circle next, it's going to cut my arc third, and then it's going to cut that outer profile, and then 1, 2, 3, 4 in the order I selected it. And there, I may have it selecting that for a specific reason. What would be a great reason for selecting vectors other than, I wanted to cut in a certain order for, like, if I'm doing a wasteboard and all. But when I have jigs on my table, and or multiple boards on my table, let's say that I have multiple boards. Let's say that these boards have text in them. Maybe I'm making a sign, and and I want this to cut this board first. When it's finished with this entire board, both the V-Carve toolpath that I'm going to calculate using the vector selection order and the profile cut, I wanted to cut this board first. When it's done with that board, I wanted to come and do this board next, and this board next that I've got clamped on my table. Because when it finishes with this board and it moves over and it starts cutting this one, I can take this board off of the table and put a new blank board in its place, and that way when it finishes all 5 boards, I can tell it to start over, and it'll start right back at blank board number 1 and work its way through again. I can actually I can draw out my table, I can lay out where my boards are, I can have my designs on my boards, and I can say I want to do this one first, this one next, this one second, or this one third and fourth. And it will cut those boards, and as it cuts them in order, I'm able to take those boards off the table and clamp another one in its position. Now I have a jig with a specific location that every board goes into. It's not just willy-nilly clamping a bunch of boards on my table, hoping I got my spacing right and everything. I have a jig that is spaced for certain size boards that I just drop them in to these little pockets and things, and so that way that known location is the same spacing and everything I have drawn in my design. you know. So that would be a reason for using a vector selection order, is I wanted to cut in order, because as it's moving down the line, I can start pulling these off, putting them on my bench, putting a blank in its place. I could be doing sanding and all, and when it gets done with that run, by the time I grab that last board and put it on my bench and put a blank in its place, I'm ready to tell the job to start over and continue carving, especially if I'm doing the same run of the same job over and over again. So that's where vector selection order comes in very handy. But again, as default, it's working from left to right, bottom to top in a grid pattern. Now, the one thing that is absolutely vital is a lot of times, let's talk about this for a minute. Let's get rid of all this so off of here for a moment. Let's talk about this letter E. Now, a lot of times we are making signs and we're actually cutting letters out of one species of material and adhere or gluing them to another, whatever the case may be, to make a sign, or we're hanging them on a wall in our kid's bedroom, whatever the case may be. Well, when we are cutting letters out, I'm going to do 2 profile cuts for this letter E. The first profile cut, and let me get rid of these for a minute. The first profile toolpath is going to be cutting 1/4 of an inch deep, and I'm going to be using my 60-degree V-bit. I'm going to be, let's see, what am I going to be? I'm going to be on the outside of the line. Do I want to be on the outside of the line? Let me think here real quick. Where do I want to be? On a nice V cut right on that line. I'm going to cut on the line in this case. I'll cut on the line. Or I could be on the outside of the line and do a allowance offset, which means it's just going to bring the bit in that diameter and all. But I'll split the bit. I'll be on the line for this. Now, I'm going to go ahead and I'm not going to ramp or lead or anything for this. I might ramp. I'll do a nice little smooth ramp, and I'll go 1 inch. Just a smooth little ramp. And I will calculate that toolpath. Oh, select your vector. Select your vector. Calculate that toolpath. Okay. Now, when I preview that toolpath, let's come in here and preview. Oh, let's speed up the speed. All right. Let's go control. Let's open that up. Let's go on the outside of the line. I should, if my letter was bigger. My letter's, how tall is my letter? Let's see here. No, it's 4 inches. That's good. All right, we'll leave that. Let's go on the outside of the line. And let's step in. Let's do an allowance offset of a no problem, Ronnie. Let's do an allowance offset of a 1/16 of an inch. The offset, I'm going with a negative, meaning I want it to overlap my cut by a 1/16 of an inch. Overlap my line by a 1/16 of an inch. And so I'm going to go ahead and preview that selected toolpath. All right, there we go. Let's turn that color. I don't know why. Quit stabbing the color. All right, very nice. Okay, let's tighten this up a little bit. Let me go into my toolpath, my preview simulation. Going. Okay, I'm already set to good. Just want to make sure. All right, so one thing I want you to notice now, a lot of times when we're doing a toolpath, what I'm doing here is I'm doing a chamfer on the top of my letters. I like to have the letters to have a nice looking chamfer cut. And if I run this as it is and things, I'm getting, if we look at the actual letter, if we look at our letter here, on those corners, if we look at my letter here, I've got these 3 sharp inside corners and things, and I'm not getting those sharp inside corners with that that chamfer, with that router bit, that V bit. I'm getting these rounded corners and everything, and it doesn't look that great. I get the rounded corner here, the rounded inside corner here. This is an outside corner and all. So this is where I want to look at corners. I want to do that sharp external corner. Okay, definitely want to do that sharp external corner. We'll look at the internal corners in just a moment, but I'm going to do a sharp external corner. We're going to recalculate that toolpath. We're going to reset it. And one of the things that, if we preview that, oh, you son of a gun. Hold on a minute. Turn that off. Sharp external, internal. Those are internal corners. All right, now we have to allow for an allowance, the allowance for the cutout tool. Okay, the cutout tool that we're going to be using and everything. And that allowance, the cutout tool that I'm going to be using is my 1/4 inch end mill. Make sure my number lock is on. Is my number lock on? Stand by, stand by. I don't know why it's not letting me put in my allowance. Okay, so it's not going to let me put in my allowance yet, but that's fine. We'll deal with that. With the corner sharpening switched on, the cut depth cannot exceed the tool cutting edge depth. The maximum depth for this tool is 0.215. That's what my problem is. My V-bit has a maximum cut depth, pass depth of 0.2, and my cut depth was 0.25. I should have went into my tool and looked at the pass depth. Now for my 90 degree, I believe that's set for a 0.25, but my 60 is 0.2, so I need to make that match. Okay, so that was a main problem. Now if we look, if we zoom in, you will see that we have some additional vectors in here. These lines here, here, and here. That's where that bit, as it cuts and things, it's going to make that nice sweep in and up. It's going to ramp up to make those nice V cuts. And again, because my bit was set to 0.2, I didn't pay attention, and that's why it wouldn't let me do that a moment ago, and that's why I didn't show that. So let's go ahead and let's preview that selected toolpath. Nicely done. All right, let's get that straight on here. All right, so now, other than the bottom, because the bottom, if you look at the actual vector, it's not a square internal corner on the bottom, it's a radius. It's a radius. Before you guys start saying, how come it didn't do the bottom? It's a radius, but I have a sharp internal corner here, here, and a internal corner here. So let's look at our 3D view again. So now I've got this really nice looking chamfered letter and things, and now I'm going to cut it out. So I'm going to go back in and I'm going to create my second profile toolpath. This one is going to be cutting all the way through my material. I'm going to be using my 1/4 inch end mill. 1/4 inch end mill. I am going to, I've got the sharp corners already still selected, and I'm going to come in and I've got to that allowance. Now right now I'm cutting on the outside of the line, meaning that my bit, if I look right now, let's close this for a moment, and if I click on my toolpath and I go into solid mode up here, all right, so right now my bit, there's no offset and everything, it's cutting right up to that line, creating that chamfer. Well, my profile cut, that outside of that bit is going to be running, it's going to be running on that line, right? Well, I don't want to get rid of my chamfer, so I need to offset half the bit distance. Offset half the bit distance. So if I come in here and I come into that 0.75 cut depth, I'm going to create a allowance offset, and I want that nice sharp corner. I don't want that radius corner. Oh, let's turn corners off for this one. Sorry. Allowance for offset is, turn that one off too. I'm going to calculate this, and if we look, didn't do the offset because I'm an idiot, bear with me a second. Offset, my V bit is 1/4 inch, so 0.125. We're going to calculate that. Let's turn off this toolpath. So now you'll be able to see that we are, we are stepped away that that half of that bit and all. And notice, you see here, if I continue right now my run on this, if I look at this toolpath, all my pretty sharp corners and things on those external corners, they're going to get rounded off, and I don't want that. I want nice square corners and all. So we've got to come in and we're going to go back to our corners, and we're only going to check off the sharp external corners, and we're going to calculate. Okay, so you see how we get that sharp corners because we're doing this nice chamfered letter and all. And so let's go ahead and preview that profile cut. Oh, don't be a dumbass and choose the 60-degree V-bit. We want to be an end mill, excuse my language. End mill, wonderful. Let's reset, let's recalculate that. Let's reset that preview. I'm such a goober. All right, let's preview that first V-bit. All right, there's my chamfered letters and all. Let's go ahead and choose our profile toolpath. Let's get that cut out. Beautiful, beautiful, beautiful. Now, let's look at this. Now, there's nothing we're going to be able to do about the radius here on the corners with our cutout. You're going to have to use a chisel to chisel those away and things. But this lip around our chamfer, we can absolutely do something about that. My stepping in the 1/8 of an inch, If we look at, let's go to our 2D view on that toolpath and solid view and things. Or my stepping out, should I say, that 1/8 of an inch was a little bit too far out. I shouldn't have went an exact 1/8 of an inch. Possibly a 0.1, or something. I'm going to move back in. I'm going to sneak back into that cut, that 10 thousandths, 20 thousandths of an inch on this mass depth here. So I'm going to go right now, I'll just go the 0.115 and calculate this, and then we'll run that cut again. And let's see if that eliminates that lip, which I do believe the 10 thousandths of an inch cut is going to, yep. All right. So now we've got this really nice decorative, nice chamfered top of our letter. Really decorative in design. Now our internal corners right here, we'll just have to take a little chisel and square them up. And let me point, let me get this pointed the right direction. Bear with me, let me get it on the screen for you guys and girls. Okay, but this these little 3 corners here, we will, because of the radius and the size of the router bit, we will have to get a chisel and chisel that out. If I were to have used a smaller end mill, then that internal cut on those 3 edges is significantly reduced to where it's almost invisible to the eye. But I'm anal, so I would do a little cleanup, little sanding and all to square up those corners, a little file and everything, just kind of square them up. But by having corners selected, and my external corners selected, I get that nice, crisp, square outside corners and things for this nice chamfered letter that I can hang up on my wall or mount to a backer board and just give it a really high class, classic touch and things. So corners are awesome. Now we want internal corners with our V-bit, internal sharp corners with our V-bit. We want external corners with our end mill, and so I wanted to basically give you guys a look at what is ramping and how to utilize it to our advantage. What is leads? What are orders? Our carving order. Where do we start? Start points and things. And then how do we deal with, if we're doing something like this, a decorative design or whatever, how do we deal with our internal and outer corners of our cuts? And if we look again at the 3D view and we come in here and reset this preview, that internal corner slopes, daggone it. That internal corner selection, what it does is it provides us with additional vectors. These 3 additional vectors, 1, 2, 3. And it's that upward motion with that V-bit that gives us that nice, clean, crisp corner cut. That's what the internal corners does for us. It's kind of a 3D motion. It's moving upward, creating that nice upward motion. That's why when in corners it says corners 3D. Okay? And by the way, I was trying to enter a number in this box because I'm an idiot and I forgot that that is not an entry box. It is a dialog box. It is telling you the allowance for the cutout tool. It literally specifically tells you the allowance needed for the cut when you do the cutout tool. So that 0.1155 that it's displaying to me here, if I would have looked at that and not been an idiot earlier, when I come in here, when I was trying to create my offset, I was close with the 0.115, but if I would have stepped it up to the 0.1115, that would have given me the optimal offset for that chamfered cut. It was actually telling me in that corners tab, it was telling me what the allowance was for my cutout tool, what allowance I needed to use based on the bit and all of my parameters and my sharp corners and everything. It was actually telling me what offset to use. And if I would have came in here and created using the offset it told me to use, I would have been perfectly right on instead of having to sneak up to the cut. Okay, and I was sitting there trying to type into that box like it was an entry box, and it's not. It's a dialog box. So if we preview all the toolpaths, we get that nice chamfer, and then we get that nice profile, nice clean transition between the chamfer and the profile. Perfect every single time because it told us what offset to use. Gotta love this software for being smarter than we are sometimes. So if you ever get into wanting to carve out like initials for people, 4 or 6 inch letters and things, and they can build their name or hang them on their bedroom walls, or they want a board, maybe a walnut board with some friggin' cherry or maple letters glued to it, whatever. Consider the nice chamfered effect top. That's one key thing. And then how to use your corners option in your profile cut. Okay, I think I beat that one to death. All right, guys and girls, let's talk. Let's open it up. Any questions on the profile toolpath and all of these options and things? Our ramps, leads, orders, our start at our corners or anything. The separate last pass, adding tabs. We didn't really talk about adding tabs. When you edit tabs, that's basically, you can't add tabs to text, by the way. It's got to be converted. Add tabs to text. If I click yes, it'll convert it to curves, and then I can add tabs, kind of thing. Tabs, when you click, you'll see an arrow pop up, a check pop up. But you can hold down your left mouse button. You can drag tabs around to different places. You can, instead of just sitting there clicking and adding tabs yourself, you can tell it that you want a constant number of tabs and click add tabs. It'll put however many numbers you put in there. You can come in and tell it you want a constant distance between your tabs. If I want a constant 2-inch distance with a minimum of 1 tab or a minimum of 2, I'll do a maximum of 8 tabs, and I click add tabs. It will give me a 2-inch distance between my tabs. Now you see this right here, we never want tabs on an inside or outside corner, right? We never want a tab on an inside or outside corner. So if we uncheck the first tab at the machining start point, if we uncheck that, and we add our tabs, then it's not going to put them in the corners and all, and it's going to put them in more usable places. And then from there we can come in and kind of adjust if we want to get further away from corners and stuff like that, however it may be. But that if you have it checked off to use at the first start point, it's going to throw the tab right there in that start point every single time, right in that inside corner. So tabs, you set your width of your tabs, your length, and your height, your thickness of them, and you can go ahead and cut. Now these will create a square typed tab, however thick that you want it and all. If you choose the option of a 3D tab, what it does is on the outer edges it's much thinner, and then in the center of the tab it's 1/8 of an inch. If I have 1/8 of an inch thickness, then my tabs kind of cone up and down, so it's a little bit thinner tab. It's only thicker It's only the 1/8 inch thick in the center, towards the center. That's what a 3D tab is. All right, so let's go here. Baron says, just a question. Were we going to cover anything on the Photo V-Carve program? Tonight was a profile class, Baron. But we can talk about Photo V-Carve for a moment. We were talking about the profile toolpath. I remember telling you that I would probably do a class on Photo V-Carve, but to be honest with you, with running late and everything, I forgot all about it. So why don't we do I know you're wanting to do Photo V-Carve like, this week and all your carving, you've been playing around with it and all, but today's Wednesday. Monday, I'm not going to have anybody interrupt me Monday, hopefully. So we're going to have class. We will focus on Photo V-Carve. It's going to be a short class. There's not a lot to it, but we'll focus on all the ins and outs. Now, let's talk about Photo V-Carve for a minute, just to give you a little taste of what it is. And you'll have to bear with me. I never use Photo V-Carve. So I own it, but I don't use it. All right. Now, Photo V-Carve is a 2-trick pony. It slices and dices wood with a series of lines at different angles and things, depending on the angle that you set, to ultimately reveal an image when it's cut magically. The deeper the cut, or the deeper cut part of the cut, so those lines are the darker part of the image. The shallower cuts are the lighter part of the image. Now, me personally, I've never had a good result with the Photo V-Carve unless I'm working with cherry and I paint the face of that cherry white, and then I V-Carve, and then I can start to see the picture and all. Grain selection in your wood and your materials is absolutely crucial for effective results. If you are Photo V-Carving and you are carving in a grain that is quite wild, then your results are going to be quite miserable. And I will give you some photo illustrations to show you that. Photo V-Carve. Alright, let's move this tab over onto the screen here. Hopefully I don't start buffering. Jimmy buffering. Alright. Now, okay, let's talk about grain selection for a moment. Okay. This grain in this oak, by the way, oak is the worst thing to Photo V-Carve on because it's an open pore grain. Very open pore grain, and all the details get lost in that open pore grain. Now in here, a very kind of wicked grain going on and stuff, and you've got your Photo V-Carve. That grain, you can see it coming through the face and everything. Your darker lines because of the darker part of the grain and all, not a very good wood selection and things. So wood selection important. Let's look at another one here. That's not a Photo V-Carve. Here we go. All right, so here is another example of grain. This would have been a very nice Photo V-Carved image, but there's this friggin' cathedral grain that's going right through his face that's absolutely, totally distracting. Can't once take my eyes. The first thing my eyes go to, not the cute little kid in the photo of my grandkid, whatever the case type of may be. All I can see is this freaking cathedral grain running right through his face, and that's the only thing my eyes focus on. So we want to be absolutely aware of the grain that we're in our wood. That's why I paint the surface of my board, so I have a consistent surface. Okay. That is a Charlie Reese they're on. this is a decent example of a nice grain selection on a photo V-Carve option. Now this one actually has some highlights and things in it, so it almost makes me think it's a lithophane more than a V-Carve, but it is actually a photo V-Carve because I can see the actual lines. Now what this individual has done is he's actually added some stains and dyes and things, to accent, some coloring to accent this image. Fabulous job, great quality, he's done fabulous. Let's back up Jack to old James Dean, a Vectric favorite. Decent, decent photo V-Carve. The grain's not really too distracting in this piece of cherry and all, but it's a dark wood, right? It's a very dark, carving, and a lot of times now I've carved in cherry, I've photo V-Carved in cherry, and I've had to stand back to be able to see the image and to really make it out. Now some lighter woods and everything, that's laser engraving, that's cheating. No, I'm just kidding. Some darker woods and everything, this is a nice example of a photo V-Carve on cherry and all. So but painting the surface of your board gives you, like I use white, gives a nice contrasting color to the grain of the wood, to that red grain of the wood, and it really, you can set it up and stick it out. And this was taught to me. I was never getting really good results. And I went to a customer's house in, I think it's North Carolina or Tennessee. Can't remember the gentleman's name. And he really got into photo V-carving, for his photography studio and things. And I was like, man, I can never get good results. I just can't see the picture. You have to hold the board at a certain angle. You got to do this, you got to do that and all. He says, well, here's what I do. And he painted his boards and all. And he had the boards set up on a fireplace mantle where you were, standing, 6 feet away or what have you and all. And you could, beautiful, clear as day type photos. I was like, man, that's a game changer for me. And so I started painting the surface of my boards with a solid color before photo engraving, photo V-carving. Oh. Now, photo V-carving is basically taking and carving a series of lines at different angles and things, till you obtain the best contrast and all. So if we look at our photo V-Carve software, first thing we have to do is load an image. Now, the question is, since I lost many of my files, do I have anything on my backup that would resemble an image? Bear with me a second here. All right, we'll flex it out there for you guys and girls. All right, back when I was a young girl. All right, so can you use a laser photo V-Carve? No, unfortunately you can't. All right, so we've got our image, and we've got our image loaded. So now we're going to, if I wanted to make a particular color transparent, I could select that color and it would make it transparent type of thing. But that's if you have a solid color background like a green screen or something, being able to click on that green screen and making that color transparent, so it just disappears out of the background and you only have your subject to focus on. That's ideal, especially when you have a lot of wild stuff going on like I do in this background with fences and trees and skies and things like that. But unfortunately I don't have a solid color to throw in there. So we're going to now jump from the image to the material. Okay, now generally you want your material to be roughly the same size. Roughly you want your material to be the same size as the photo. Generally, 9 times it is. So let's go. I'm going to go with a 6-inch by All right. And you see it's wanting to keep the aspect ratio of my photo, so I'll go with a 6 by 5 876. Now I want the XY origin. I could, just like when we're setting up our machine, you can start from the center of your project board or one of the four corners. I'll start from the bottom left. I'm going to touch off on the top of my board, and my material thickness is going to be a 1/2 inch thick. And I'm going to apply my material size. From there, after applying my material size, now I move to step 3, setting the cutting parameters. Now the cutting parameters is where we're going to talk about our V-bit. Now you may get better results. You may get better results with finer bits like 22 degree V-bits and 11 degree V-bits versus the 60 degree V-bits or the 90 degrees, you know, that we typically use, because those lines are going to be very wide and fat and all, depending on their depth and stuff. You may want a finer bit, 18 degree V-bit or 22 or something, and that may give you the optimal results. I'm gonna use this 60 degree 1/4 inch V-bit here, and my maximum depth, my carving depth, my maximum depth on this is as a default for me, I'm working with a 0.015 carving depth and everything, which is a little 10 thousandths of an inch, not very deep at all. Let's go ahead and give it some depth. So we'll go 0.03125, 32nd of an inch. And my line spacing, your line spacing, how far apart you want them spaced, is going to determine how many number of lines there are. So I want 100% line spacing. For most cases, I'm going to do 100% line spacing, and you may step it up to like a 115 or 125, whatever it may be, but I'm going to go 100%. That's going to give me 237 lines that it's cutting. And the distance between the lines are going to be a little over my 32nd of an inch. The number of passes is going to be 1. It's just going to do 1 pass depth and stuff. My line angle is going to be very important. Going a 90 degree in one direction, or a 0 to 90 degree in one direction may, depending on the grain of my wood, really make the grain stand out. Like, holy cow, that grain is just like obnoxiously in your face and you can't even see the picture, kind of thing. So grain line angle plays a role with that as well. I would generally be at a 30 or a 45 degree angle, but I know some people that like 0 or 90. I know people that like to just kind of mix and match and figure it out there. So I'm kind of a two-trick pony, and since I don't use this as much, I'm going to be at either a 30 or a 45 degree angle on that. I have very rarely used a crosshatch option on a photo V-Carve. I don't really know of any instance where you would use the crosshatch option on a photo V-Carve. Now, if I calculate this cut and everything, bear with me a second. Get back on the screen. Oh, geez Louise. Gotta love photo V-Carve. Stand by. Preview. There we go. Zoom to fit. Zoom to fit. Alright, so if we look at this, detail is not that grand, right? Okay, if I was cutting this in a piece of maple, I'll go with a light wood. Let's go with cherry. Let's go with a cherry, just so you can see, like, if I was using cherry. Cherry, is cherry not even an option? Oh God, photo All right, I'll stick with maple. My fill color, I'll go with light. Yeah, that'll work. Where I'll leave the fill off for a minute. Let's go back up to the cutting parameters. All right, so right now I'm not going to get the best cut in the world with this. I'm not going to get the best look. So let's change some things up. I'm going to decrease my line spacing. I'm going to go about 130%. I'm going to change my angle ever so slightly. I'm going to go 45. I may invert the light and dark. Normally the invert light and dark is when you're working with lithophanes. You always invert on the lithophanes, but let's see what that does for me here. And I'm going to reduce the depth of cut to 20 thousandths of an inch. Let's calculate that. All right, let's turn off the invert light and dark and calculate it again. All right, a little better. Let's see here. Let's give it some color. Oh, what would be a damn good color here? Not white, that's for sure. Bear with me, guys and girls. Let's see here. There we go. All right, so getting a little bit better, starting to see a little bit more, things here, but I'm really losing all the details in the face. Can't make out the face whatsoever, have you? At all. So now if I tilt this on its side and oh Jesus Christ, there we go. It won't let me pan or move things around. All right, so let's go back to the cutting parameters. And let's see here, we'll go off the 45 or 30 that I usually do. Let's go with because that one's actually not too bad at 45, but let's go with a 0-degree angle. I need a little angle. Let's go 5 degrees. And let's decrease the number of lines. Calculate that. No, that 5-degree angle running across my mouth leg makes me look kind of goofy. So let's go with a 60-degree angle. Okay. I want to go back up. I'm going to go 110 degrees. There we go. Starting to get a little bit more contrast in there. I think that's about the best I'm going to get with this 60-degree angle, 0.02. Let's see if we increase. If I go too deep, it's going to take away the effect. But if I go a 32nd again, at a 60-degree angle, 212 lines, calculate. Yeah, see, too deep takes away the effect. So let's go with a 0.015, which is my default number. I'm going to end up increasing the contrast in a minute. I'm going to calculate this. Okay. Getting better. Let's take the contrast up now to about 25%. Getting better. Let's 51%. Let's see, did I overshoot it? Alright. Let's turn off the fill color for a minute. Yeah, some type of dye or stain is going to help. Let's see what a black looks like. Gives it kind of that black and white photo look. So, you know, you've just got to, as you can see here, you've just got to play around with your numbers. You've got your depth of cut, your line spacing, your line angle, your contrast. All of these things play a role. The grain of your wood plays a role and stuff. This is about the best I'm going to be able to get this image. And, you know, in the, you know, with these parameters and things, I don't think I could, if I went with a, let's say a straight 0 degree angle, no. Straight 90 degree angle, no, right? You got to have some kind of angle. For me, I'm a 30 or 45 kind of guy. But that 60 actually wasn't too bad. So that's 30 degrees. This is 45. And then this is 60. Which, you know, 60 is not too bad. Let's decrease the contrast a little bit. I think I'm going to end up being about 33% on the contrast and all. So this is about where I'm at. You know, so this is photo V-carving. And there's a lot of variables that go into it. There's only 4 steps to this program, to this photo V-carving part of this program, not the lithophane part, which it does fabulously well. It does very good with the lithophanes, but the photo V-carving, I don't know. No, I'm not the biggest fan. But you just got to play with your numbers, your parameters and all. If I changed my bit, would that make a difference? If I changed my bit to a tighter angle, let's see if I create a new V bit that is got an 18 degree angle. And I calculate that. No. You know, so I don't know, you know, if I use my smaller angle bit, is that going to help? If I went with a bigger bit, you know, does that make a difference? Do I need to be, you know, working with that type deal? No, right? That's ridiculously stupid right there. If I take this down to 015, my default number, no. So it's really just something you've got to play with, unfortunately. Now, the photolithophane side of things, you're in the same program. There's not something like it's not like there's something that says create a lithophane type thing. It all comes down into your bit null. So when we're setting our cutting parameters and everything, let's make sure. Load the image. Material setup is good. Alright, so on my cutting parameters, in this case I'm going to be using a ball nose. So 1/8 inch, 1/16 inch, whatever you got. I will say this: the 1/16 inch or a finer detail does better in many occasions. In this case, I'm going to use an 1/8 inch ball nose, and we'll click OK. And my maximum carving depth, I'm typically at a 0.16. Stand by. I'm missing a parameter. Bear with me, guys. I don't want to get stuck on this, but bear with me now that I'm kind of into it. And let me... Where is the parameter? I want to invert light and dark. I know that one. I want to invert. I don't want a line angle. I guess, yeah, 45 degrees. Oh, let's see here. My line spacing, you see how the slide bar only gives you so much room. I'm actually going to type in 50% here. You just type it in. I'm going to invert the light and dark, 0.2. This cut depth got to change. That's got to be 0.1. Okay, so I'm going to use my 1/8 inch ball nose. I'm going to go with a 0.1 cut depth, 50% line spacing, 45 on the line angle, and I'm going to definitely invert the light and dark because I want the light being down. But I'm not going to mess with the contrast at all. So we're going to calculate this. And this is going to generate kind of a rough cut. Okay? And you got to remember that we're carving, and let's turn off the color. Let's actually make it use fill color, and let's make it white, like a lithophane. Alright, So one thing you got to understand is we have rough cuts and finished cuts just like anything, but it's how we set our parameters. And so this is going to be set up as a rough cut. So right now it looks like behind. And so we would calculate the tool path, so on and so forth, using our digital wood carver inch post processor. And if it's not in your list, you can add it, or you can use the generic G-code inch.tap, but you can add it just like you do in your Vectric V-Carve software or Aspire or anything. Now, once we save, that particular tool path, then we got to come back and we got to change up our parameters. We got to, now we got to start looking at our finish cut and things. And this, on the finish cut and all, this is where I talk about the diameter of the bit is going to really, really make the difference. What am I excuse me, what am I trying to say? And the line spacing and all that stuff. So let's go back now. Let's imagine that we've already created the rough toolpath and saved it. Now we're going to come back and whether we use the same bit, what have you. Now we're going to actually change the parameter of the bit. I'm going to come in here and go select, and I don't have it in here, so I'm going to come in and change it up. There's my 1/8 inch ball, but I'm going to go ahead and change this, and I'm going to be using a 1/16 inch end mill, but I don't have it in there, so I'm just going to change this to 0.0625 diameter. Okay, ball nose, not end mill, ball nose, sorry. Pass depth is fine, speed and feed is fine, click apply. Okay. Oh, hold on a minute. Change the name up here. Okay. Now, my maximum depth of cut is going to be the 0.1, just like we set the rough cut for. But now my line spacing, now we're going to get really tight. And again, it only goes to 100 if you use the slide bar. This time we're going to type in, just like we did the 50%. We're going to get really tight. The more lines, number of lines, the tighter the image is going to get and everything. Again, our line angle is going to be pretty much the same as the rough cut. We're going to invert our colors. We want the light down and the dark up. We want to invert, same as before. And as far as the rapid gap, same thing, that can be fine. So we'll go ahead and calculate the finish preview. Okay, and now we can start to actually kind of see me, right? And so if this were, I wish there was a way to simulate the kind of like a, like there was light or something in there. On the fill color, let me go with kind of almost like a light gray. I'm trying to imagine if there was light coming through, what it would be. Let's see, if there was light coming through, it'd be kind of a pale blue type thing, where you got your darker and lighter images in them. That would be your, and that would be creating your lithophane, and you would carve that usually in 1/4 inch material, and you would carve in acrylic, cast acrylic, or soapstone, or corian, white corian or bone colored corian, or things like that. But the lithophanes, they're illuminated from behind and things like that. The Photo V-Carve software does very, very well with lithophanes. I have an issue with the V-Carve parting of it, the part of it and all. But the lithofanes, I've never had an issue. Really, really good stuff. And these parameters, 0.1, 15 on the finish cut, 45 degree, 0.2, invert your color. They're pretty much, my defaults. And guess where I got them from? From the instruction manual that came with the software. I've never had any reason to vary from it because I've gotten near excellent results every time. And these are my numbers, you can play around with it. You can try different things, but if something works, why F with it, right? All right. Okay, so we got to get off Photo V-Carve for now. Well, really, that's the class. There's nothing more to have a class on it. But we'll explore Photo V-Carve a little bit more. We'll do another partial class on it because that's all. It's a 2-trick pony. That's all it does. And there's only 4 steps to it. Once you have this and it's calculated, come into the save step 4 and, set your tool parameters. How fast you're cutting, how fast you're plunging, your tool pass and save, and that's it. Okay. Hey John, how are you doing there? Okay. All right. So, Wayne Henniker asked, does Aspire have something like Photo V-Carve? Aspire does phenomenal with lithophanes. It has absolutely nothing like Photo V-Carve as far as the lines and all. Absolutely no. Thank God. No, it doesn't. But it does lithophanes, the 3D dimensional photos that carves in. And just as I showed you images of a lithophane and I talked about Photo V-Carves and things like that, lithophanes can be carved in wood, or they can be carved in acrylics and everything. Lithophane with the right stains and dyes and everything. This young lady, I can't remember her name. I want to. It's Robert, but it's a female. She's got a very nice technique. If you actually clicked on this and went to the PDF type thing, she uses Photo V-Carve to do a lithophane, and then she also walks through the staining, sanding, toning, sanding, and all to really make her lithophanes pop. And do really, really excellent jobs with them, and that's not one of hers, but lithophanes, you can carve lithophanes in wood and stuff. That's not a lithophane, that's just a 3D carving. Who are they trying to fool? But the lithophanes do very, very well in Photo V-Carve, phenomenal in Aspire, and so they don't have to be necessarily carved in acrylics and have lights behind them and stuff. You can carve them in wood too, but what really makes them pop is the stains and the dyes and the toning and the sanding and things to kind of really get those accents and shadows to pop and all. That's where it comes. The finishing is the key. And this young lady has a very nice tutorial on her finishing technique at this link here, Photo V-Carve Relief. She does a very good job of showing her technique. All right. That being said, now let's go back up. Chuck Brazy says, is it worth adding a second end mill toolpath for a finer end mill to clean up those inside corners and use the bigger end mill first to handle the bulk of the work? Well, Chuck, you could. On that E when we were cutting it out, I mean, if you're you don't want that first end mill, the heavier end mill, cutting all the way through, right? Because then your letter's going to be cut loose, and there's no sense of using a finish end mill. You could run, a larger bit and then a smaller one, but you're doing a profile cut. It should be once and done, right? So if you don't want to chisel out those corners and all, then use an 1/8 inch bit to cut it out. If it's thicker wood, maybe it's like a 1 inch thick and all, and your 1/8 inch end mill doesn't cut that thick, then it's kind of irrelevant to be using a smaller end mill anyway, because most of them only have a 1/2 inch cutting depth and things like that. So you use your bigger end mill and you do some tool work afterwards. So no, in my honest opinion, it's not worth it. Alan, you asked the question, I answered. Can you do laser with the photo V-carving? No. Does Aspire have something like photo V-carve? I'm repeating myself. Select the 22-degree V-bit. What does that look like? The 22-degree V-bit. Let's go into cutting parameters. 22. That has kind of a flat bottom. Alright, 22-degree V-bit, maximum cut depth is going to be 0.01. Number of lines, 133. Angle, 60. Turn that off. Let's go to about 30%. Contrast, 0.2. Calculate. Let's turn off the fill color. Alright, we got to give it a little bit more cut depth because it's not cutting deep at all. So let's go 0.03125. A little darker. Let's stand that straight up. And let's take the contrast down and recalculate that. Let's take the contrast back up. Recalculate that. So the 22-degree V-bit doesn't look too bad, but really I've got there's no eyes or anything like that. It's just black holes. 22-degree, 18-degree, 60 smaller bits are going to be much better than the wider ones type of thing. Your smaller bits may even be better type of deal. But that's what a 22-degree V-bit would look like, Chuck. Okay, thank you. So anything that the laser would do to make this even better by changing the laser strength. You can't use a laser with photo V-Carve, Baron, so I'm trying a little lost in your question there. You can, now in 9.5, you can set a grayscale. You can edit an image right there in Vectric 9.5 if you haven't downloaded that yet, do so. And you can now edit an image and make a grayscale off you're working with a laser like our little digital laser engraver. For photo engraving and stuff, for sure, but not with photo V-Carve, Aaron. That would be your regular V-Carve software. Any more thoughts on the DWC conference? Yes, John, I'm going to be posting. I kind of dropped the ball on that one. My fault. Burrow reminded me the other day. I've got to put my posting out in Facebook. I'll get that done probably in the next day or two about the conference, and I'll be putting out a poll and just a statement, and would love to get all of you guys' feedback. That's all I'm going to pretty much say about that. I'll let the post do the talking when I type them out and stuff, but thanks for bringing that back up, because I actually dropped the ball on it, and Bro reminded me, said, hey, did you ever get those posts out? And I'm like, oh, no I didn't. Gotta get them out. So I'll get those out to you guys. And do you use a flat bottom or a flat tip V-bit much? The only time I use a flat bottom V-bit or flat tip V-bit is when I used to use it a lot when I was actually using it as a rounding bit for my 4th axis, a rounding tool. But I don't use it a lot. I have one, and it's for specific needs. If I need that flat bottom cut, if I need that nice little flat bottom cut in a particular design or something, and instead of the V-bit having to do all the work, when I choose to use a flat bottom in my V-Carve Toolpath, my bit having to do all that work and stuff, I just do a regular V-Carve, and it already has that flat tip on it, so it kind of creates that flat bottom for me. And if there is any cleanup and stuff, usually there's not, because my step over and everything, but that's what I would use that for. Or I use a flat bottom V-bit for actually as a rounding tool for square stock to round on my 4th axis. Now I've used my surfacing bit, my 1-inch surfacing bit, but I used to use a flat bottom V-bit because the angle of the V cutter was real nice for not being so aggressive on the corners and things like that. Alright, ladies and gentlemen, well, are there any more questions? Let me get off this ugly mug right here. Any more questions on anything that we covered tonight? I really want you guys to start, I don't know if you knew about all the options in the profile toolpath and if you've ever used them or worked with them at all, but be sure to check them out. Really get the hold of your leads. Leads are wonderful for removing tool marks and things. Ramping helps extend the life of the bit. Your separate last pass, the order that you cut things in, where you start from as far as your start points, and then sharp external and internal corners when you're doing things like letter cutouts or shape cutouts where you have a nice little chamfered edge. And it's a nice little technique when you want, even if you were cutting out a circle or something, you wanted that nice chamfered edge around the edge of the board and all. Your corners option and profile toolpaths is excellent for that, giving that nice little chamfered effect. The Vectric Stack Text demo uses a flat bottom V-bit. You're wondering, in a demo that I've done, because I've never used a flat bottom bit in any of my demos, but is it like a Vectric demo or something that you, one of the Vectric videos and all where they use the flat bit? Because they're probably using it as a dual purpose bit in a way to where it does the flat work and the V-carving. Have a good night, Chuck. Yeah, William, if that's a video or something, not one of my videos for sure, but if that's a video or something, let me know what it is. I'd love to check it out and see how they're utilizing the flat bottom bit. Flat bottom V-bit. Alright, Chuck, you have a good night. Everybody, I want to thank you for your time. Y'all have a wonderful evening. And, no, the Vectric video. Okay, I'll look at the Vectric video. and see, because that actually intrigues my curiosity. I really want to see what they use it for, because hey, I'm always up for learning things. See if there's a purpose for using the flat bottom bit. Hopefully they explain the reason behind it. I'll definitely check that out. Thank you. All right, I say it 100 times. I'll say it again. All right, guys and girls, y'all have a wonderful night. I'm not sure what we're going to be doing on Monday, but we will explore a little bit more into V-Carve. But really, that tutorial I just went over in the V-Carve, that's pretty much it. I mean, it's a two-trick pony. There's not a whole lot to it. But we'll look at some different explorations and things and all, and we'll talk about that. But as far as laser options, let me get into the 9.5. I've still got to update to 9.5 and everything. Let me get into that a little bit. I want to check out some of the new tool options and stuff, like the rotary and all, but the new picture editor is awesome. I want to check that out. And I don't know if that picture editor is in V-Carve Pro. I know it is in Aspire, but I'll check V-Carve Pro, see if it's in there as well. I got to find out what all is new happening in 9.5. Once I know, you'll know. I'll make some videos on them and stuff. And until then, see you soon. All right, guys. Have a great night.